Assalamualaikum and good morning to Sir Fairuz and my friends. My name is Fatina Zulaika binti Hishamuddin, and today I will be presenting on the prediction on hand-arm vibration exposure cause effect among grass cutting workers in Malaysia. First of all, I will be talking about the introduction of this journal. First, the definition of hands-transmitted vibration, or well known as HTV, is a common physical hazard for occupational safety and health, which is caused by harmful activities to workers who use vibrating equipment in their routine tasks. Next, I will be explaining to you guys about HTV evaluation. HTV evaluation is an important requirement for the risk measurement, evaluation, and assessment of hand-arm vibration exposure among handheld vibrating machine workers to be taken in the monitoring process of the safety and health management. The function of HTV evaluation is to assist employers in measuring the exposure of hand-arm vibration syndrome. Next, to reduce the cost of occupational rehabilitations and work-related injuries in workplace caused by the vibrating machines. Before going further to this journal, we will learn about HAV injuries. So, HAV injuries begin with the workers being exposed to vibration of the machine. Then, the vibration energy transmitted to hand palm. Hence, they are experiencing discomfort or pain after operating handheld vibrating equipment at workplace. Due to the magnitude, frequency of using the equipment, and duration of HTV exposure at workplace, the discomfort will lead to an increase of severity and symptoms and will experience hand pains and injuries. What is the importance of the risk measurement, evaluation, and HAV exposure among handheld vibrating machine workers? First, the statistic of occupational accidents by sector. Until December 2013, there are 161 compensation claims cases of skeletal disorder and 110 from the workers applied for Social Security Organizations, SOCSO, for compensation claims under the item diseases caused by vibration machine. Furthermore, to improve the risk control measure, even though the standard operating procedure to monitor the diagnosis of HTV exposure is available, there is a need to improve the risk control measure by engineering or administrative of HTV exposure and to investigate the interactions between variables, especially in Malaysia work industry. Lastly, to predict HTV exposure prevalence to HAV syndrome by using health cause effect. A study by Su stated that the presence of the symptoms associated to HAV syndrome and the high level of daily vibration could contribute to the initial factor for controlling HTV hazard based on work activity. Hence, the analysis of cause-effect relationship between the HTV and the severity of HAV syndrome assessment need to be reliably tested.
The first step of data collection is called hierarchy assessment and analysis. The data collection starts early in the morning during roll call activity. After that, each section of office subcontractor of handheld grass cutting workers was called for explanation associated to Havera questionnaire. The interview and observation technique were used to answer the Havera questionnaire. Lastly is professional judgment by the author assisted by NIOSH staff is sufficient to observe the health effect, especially in selecting the numerical scoring due to finger bleaching or color changing. We are discussing about predicting cause-effect health model. Firstly is linear modeling technique, which is multiple regression. Secondly is artificial neural network, which is ANN. There are 5 instrumentation are used in this study. Firstly is human vibration meter. Secondly is 3-axial accelerometer. Thirdly is dynamometer. Fourth is Havera questionnaires, and lastly is job hazard analysis form. The next methodology is performance index. Performance index is mean square error, MSE, and regression are quantitative value. The MSE depicts average square difference between prediction and input. The R measure the correlation between prediction and input. Lower value of MSE are better, while R value of 1 mean it is close relation.
For the next methodology, the phase 1 and 2 performance index results of prediction continuous Havera cause effect of both hand grip strength and numerical scoring held model among handheld grass cutting workers are divided into two sections, which are regression R and the mean square error MSE value. As we can see on the slide, the R value is shown in percentage. For R value, for both hand grip strength and hands numerical scoring have found that the neural network prediction model regression value were close to 1 compared to the linear prediction R value. The highest R value was neural network right hand grip strength with 0.9980, and the lowest R value is the linear left hand grip strength, which is 0.93987. For mean square error values for both hand grip strength and hands numerical scoring show that the neural network prediction model are close to 0 compared to the linear prediction MSE value. The small value of MSE depicted a close relationship between a significant Havera cost and effect variables induced to loss of hand grip strength and finger branching. Next, we have the results testing of linear and neural network Havera cause-effect health model have been divided into two sections, which are hand grip strength test and hand numerical scoring test. For hand grip strength test, the difference between linear and neural network relative error for right hand is between negative 0.356 to 0.109. Meanwhile, for the right hand is between negative 0.266 and 0.205. As we can see in the table, the relative error value is so small for both left and right hand showed a reliable association between head, weight, and estimated right hand daily vibration exposure. Even for the biggest relative error value for neural network right hand grip strength was negative 0.039, where the predicted value is 16.62 and the actual value was 16. While for the biggest relative error value for neural network left hand grip strength was 0.014, indicates the actual measurement was 30 instead of 30.43. For reliability of the continuous Havera prediction model based on hands numerical scoring test, all test samples have small value or relative error. The difference of relative error value for linear and neural network right hand test prediction model ranging from negative 0.686 to 0.256, while for left hand prediction model is between negative 0.859 to 0.243. For both right and left hand model show a reliable association between age and working experience. The biggest relative error for neural network right hand is 0.000, indicates no difference between the actual and predicted measurement, which is 6.00, while for the left hand, the biggest relative error is 0.0030, lead to the actual measurement 3.00 instead of the predicted measurement, which is 3.09.
As conclusion, the Havera prediction method has been developed through the process of measuring and determining variables at two different stages, which are evaluation of Havera process and prediction health effect model of Havera process. Based on the result obtained so far, it can conclude that Havera process is suitable for use when assessing the worker's health change in hand-arm vibration exposure risk before, during, and after a health surveillance implementation. This has led to a model predicted by and for occupational safety and health practitioners with expert facilities and monitoring. By proposing Havera, hand grip trains in hand numerical scoring cause-effect health prediction model by management and workers are able to monitor the health condition during hand-arm vibration hazard. Lastly is the prediction cause-effect health model was also found to be practically reliable and applicable to handheld grass cutting workers. In my opinion, this showed that Havera process provided a good indication of HAVs, which are reported as vascular, neurological, and muscular disorder. In the right and left hand prediction model development, the result demonstrate a higher reliability performance compared to the linear model for hand grip strength and hand numerical scoring assessment.